Assalamu alaikum everyone. My name is Omar Othman and we'll be going over interactive session 2 and inshallah it's very quick. Alright. So it's a very short and easy lesson. First I'm going to do a quick ECG review and then talk about the left and right deflections, and then we're going to do we're going to do 3 practice questions, and after it inshallah you'll be a master and you'll be able to finish all of these questions on the test. I'm pretty sure the doctor is going to get at least 2 or 3 questions from these. Okay, they're very easy. All right, let's start. So a quick ECG review. All right, you start with the atria depolarizing. Okay, so it depolarizes, causes this wave, and then it fully depolarizes. And at this point, it has reached the AV node, and the AV node has a delay, and we're at the delay here. Okay, and then after the delay is over, it goes through the left and right bundle branches. All right, and that's what you see here, start of the QRS complex. And then it fully depolarizes. There are some things that cause the deflections here, but you don't need to worry about that right now. And then you have the ventricles now repolarizing. So that's what you're seeing here. It causes the T wave, and then it's fully repolarized, and it's normal. All right. Okay. Now, let's go over the car-bearer circle. This looks very complicated, but trust me, this is very easy. So we have 3 leads that we know about. First, we have lead 1, lead 2, and lead 3. Lead 1, it's a horizontal lead, right? So it goes from the right arm, it's left on your screen, but it goes from the right arm over here to the left arm, negative to positive, okay? And then we have the second lead, okay? It goes from the right arm to the left foot, and then you have the third lead, lead 3. It goes from the left arm to the left foot. All right, those are the leads that we know about. But then you have 3 other leads that basically just fill in the gaps. Right, they give you more perspective, right? And that's AVR, AVL, and AVF. AVR, it's basically, I mean, you can see over here, right? You can see over here, right? You have it going from the center to the right side, that's AVR. From the center to the left side, that's AVL. And from the center to the left foot, that's AVF, okay? And it just fills in the gaps between the 3 leads, right? The important thing to note here is the angles and where they point. So here lead 1 points to 0 degrees. So start at 0, positive 30, positive 60, 90, 120, 150, 180. Here you're going backwards, negative 30, negative 60, negative 90, negative 120, negative 150, 180. All right. Okay, lead 1 is this one, we said the horizontal one. Lead 2, it's 60 degrees after that. So lead 1 here, lead 2, 60 degrees after that, it's going down. All right, it's going to the left leg, so positive 60. Okay, and then another 60 degrees after that, that's lead 3. So you can think of the 3 leads, positive plus 60 plus 60. So 120, that's lead 3, is also going from the left arm to the left leg, right? And then we were talking about the AVR, AVL, AVF. Now, is a triangle here. How did we do all this mess that it looks like? Well, we just took each line and we put all of the lines into one center, right? They're all concentric here. So, let's talk about AVL first. AVL is from the center to the left side. So, it's going to be pointing at negative 30. Right? AVF is from the center to the foot. So center to the foot, down. AVR is the only one that points away from everything. AVR is from the center to the right side, right? This is the right because, here, I'll show you here. This is the right side and this is the left side, okay? This is the right side of the heart and this is the left side of the heart. So that's why I'm talking about. All right. Okay, and that's basically all you need to know about this, okay? So normal axis of the heart, of depolarization is most around lead 2. As you can see with this red line, it's mostly around lead 2. All right? Okay. Now, let's look at what a left axis deviation is. We said that the normal one is pointing at lead 2 most of the time, right? Well, what are the times where it doesn't? And this is a deviation. This is when we know something's wrong, okay? And so let's see what a left axis deviation is. Now, if it's saying left axis, that means it's going to be going to the left side a bit more. Okay, and there's a right axis where it's going to be going to the right side a bit more. Now, normally, the normal axis is between negative 30 to positive 90. Negative 30 from AVL to positive 90. It's this all the way, all right? So it encompasses all of the bottom, I mean, you can call it right side, bottom right side, but it's on the left ventricle side of the heart. All right, and then this part, right? Some athletes have it going here. So negative 30 to positive 90, that's normal, okay? Anything away from that is not normal. So let's look at this here. Negative 30 to negative 90, right? This is on the left side, it's a negative deflection, all right? A left axis deviation, okay? And so what would cause this left axis deviation? A thick left ventricle, sorry, let's be clear. A thick left ventricle, a hypertrophied left ventricle would cause this. Why would it cause this? Because it would take longer to depolarize the left ventricle, and as we know, when it's the side that's getting the arrow points to the side that's still not depolarized. So if it's taking longer to depolarize it, the arrow is going to be pointing to the left side. So it's going to be pointing over here, okay? And this causes, and because it's going to take longer to depolarize, it's also going to have a prolonged QRS complex, right? This over here, the QRS complex, which is the depolarization, will be a bit prolonged because the left ventricle is bigger, all right? Okay. Now, how can we tell from the ECG that it's on this side, it's a left axis deviation, right? Okay. We can look at it like this. So lead 1 is pointing this way. So if lead 1 is positive, this 180 degrees, it's going to be somewhere here, right? So we can basically go step by step. Lead 1 is positive, it can't be negative, so this we can cross this out, right? Let's look at this. We can cross this side out, right? It can't be here, but it can be over here, okay? And lead 2 is negative. So if lead 2 is negative, let's go back. Let's see what lead 2 is. I'm going to do it like this. It's like this. Lead 2 is this way. So if lead 2's lines like this, and lead 2 is negative, well, anything over here is positive, so it can't be here. So it has to be, let's take a different color. It has to be over here. So the overlap is this. So that's what we're looking at. So when we see lead 1 is positive and lead 2 is negative, and we look at the overlap, it's going to be a left axis deviation. All right? Very simple stuff. Okay. Now let's look at a right axis deviation. Now a right axis deviation follows the same idea. Okay? The right ventricle is hypertrophied a little bit. All right? And that causes it to be a little bit thicker. That causes the depolarization to take longer. And we said that depolarization points, the arrow points to the part that's not depolarized yet. So it's going to take longer, it's going to point at the right side. Okay? And same idea, where, how do we tell? Right? How do we tell? We look at the ECG. Lead 1 here, it's negative, right? It's going down. So lead 1 is negative, it's going to be on this side. All right? Right. Lead 2 is positive. So if lead 2 is positive, that means this is lead 2 over here. So if lead 2 is positive, we take it from this side and we go like this. All right? So it's over here. So it's something like this. Lead 2 could be a little bit negative, but yeah, it's you can look at the overlap, and if lead 2 is positive and lead 1 is negative, that means it's the right side. What would be better to use than lead 2, but you don't really need to know this, but what would be better to use than lead 2 would be AVF, right? Anything above this line is going to be negative for AVF. So if AVF is positive and lead 1 is negative, that means it can only be this corner, this bottom left corner of this, but it's on the right side. All right? Okay. And I didn't say this, but our right axis deviation is from positive 90 to positive 80. Right? This is very important to know. So we said left axis is from negative 30 to negative 90. Right axis is from positive 90 to positive 180. Very important. And it's also going to have a prolonged QRS because the right ventricle is hypertrophied, so it's going to take a bit longer. Okay? What could cause both of these? What could cause right axis and left axis deviation? For left axis, it could be a valve disorder. So it could be aortic valve stenosis or regurgitation, right, which causes it to hypertrophy. For right axis, it could be pulmonary valve stenosis. So that's basically it. Now let's do a couple of questions. The questions are very important because I'm pretty sure the doctor's gonna get something from these, right? Okay, so question 1. Mean electrical axis was positive 60, right? Which of the following leads would have the strongest negative deflection? Okay, I'll give you guys, if you want to solve this on your own. All right, pause the video. Okay, now let's talk about it. Okay, so, all right, which of the following leads would have the strongest negative deflection? So a negative deflection basically means which lead is most negative. So asking which lead would be most negative if the mean electrical axis was positive 60. Here the answer would be AVR. Why? Okay, so we're looking at it. The angle, the mean axis is positive 60, right? So the mean axis is pointing this way. So we want to look at which one would be the most negative if this is like this, right? Lead 2 is most positive. It's like this. This is positive. This would be positive, right? They're all pointing this way. The only one that's pointing away, the only lead that's pointing away is lead AVR. Its lead is pointing like this, right? So it would be the most negative because this is where it points. We want to look at the lead that's the most negative, and this is what we see here. Positive 60, right? And so this, it would be like this. If we continue this arrow, it would be like this. All right, this side is the negative side. So the closest one is AVR, okay? That's the answer. All right, let's look at it now. Let's look at another question, all right? An ECG question now, okay. A 34-year-old patient comes to the clinic after a short episode of lightheadedness. A 12-lead ECG is recorded and shows lead 2 is negative while lead AVF is positive. Okay? Which of the following best describes the mean electrical axis? I'll give you guys a second to solve it really quickly. Alright, let's talk about it. So, we have a 34-year-old patient. This is all, it doesn't matter. Okay? A 12-lead ECG is recorded and shows lead 1 is negative and lead AVF is positive. Okay. Which of the following best describes the mean electrical axis? Now we can even solve this without the ECG, because they tell us what's negative and what's positive. But let's look at the ECG itself, right? Lead 1, they said is negative. Okay, well we can see it here, it's negative. So if it's negative, anything behind lead 1, if it's negative, that means anything that's positive would be wrong. So this can't be. Right? So we're going to be looking at this side. Okay? And now let's look at the others. Okay, we can use each one to narrow it down, but the best one to narrow it down, they even told us it, but the best one to narrow it down would be AVF, right? AVF is positive, so anything behind it would be wrong. So this is our overlap. Okay? We have this. So from positive 90 to positive 180, what did we say? It's a right axis deviation. Very simple. This is the right side of the heart, and this is the left side. All right, this is the left side. So if it's right, if you can see that it's overlapping on the right side, it's a right axis deviation. All right. All right. Now let's do the last question. Very easy. Okay. A 16-year-old adolescent comes from a routine checkup. He has a history of congenital pulmonary valve stenosis, but currently feels well. On auscultation, there is a soft systolic murmur at the left upper sternal border. A 12-lead ECG is obtained. The cardiologist notes that the QRS complex is slightly prolonged, and the QRS in lead 1 appears mostly negative, while in lead 2 it is mostly positive. Based on this information, what is the most likely mean electrical axis? All right, I'll give you 1 second to solve it. All right. Okay, let's look at the question. A 16-year-old adolescent comes from a routine checkup. All right. This the entire first part is not necessary. All right. You can use the congenital pulmonary valve stenosis or auscultation points or whatever, but you only need this part to solve it. Okay, let's look at it. All right, slightly prolonged QRS. That means there's a hypertrophy somewhere, and lead 1 appears negative. So lead 1 is negative, while lead 2 is positive. That's all you need. Okay, that's all you need. So lead 1 is negative. So that means it's going to be on this side, and lead 2 is positive. That means let's continue the line of lead 2. That means it's going to be somewhere over here. Okay, so same thing as the last question. It's going to be we see it from positive 90 to positive 180. It's on the right side of the heart. That means we have something wrong with the right ventricle. It's hypertrophied, right? And it's a right axis deviation. So right axis deviation and right ventricle hypertrophy. That's it. It's a very easy, simple lesson, right? Just remember negative 30 to negative 90, positive 90 to positive 180, and normal is in between here. This I didn't talk about it because it's not really necessary to know and what causes it. But if it's in this quadrant, it's an extreme deviation, right? And I mean, you can he only explained it quickly that there's a bundle like an extra bundle from the left ventricle from the ventricles that go into the atria, depolarizing it again. You don't need to know. All right, that's it. Okay. I hope you guys enjoyed my lesson, and yeah, good luck, guys.